Hello, today we are doing numericals from the chapter Sound, exercise 7a. Question number 1. The wavelength of waves produced on the surface of water is 20 centimeter. If the wave velocity is 24 meter per second, calculate number 1. The number of waves produced in 1 second, and 2. The time in which one wave is produced. Here wavelength is given, so here wavelength that is lambda is equals to 20 centimeter, and what is given, wave velocity is also given. Wave velocity that is v is equals to 24 meter per second. So we have to first make the units similar, so this is in meter per second, so we'll change this also meter. 20 divided by meter deci centi, so this will become 2 by 10 meter. Okay. Now we need to find number 1. Question is what we have to find, the number of wave produced in 1 second. So that is wave produced means frequency. Frequency F is equals to how much? Then we write we have to know the relation of frequency, wavelength and lambda. So we know that wave velocity is equals to here frequency into lambda, that is wavelength. So if you have to find the frequency, this will be equals to v upon lambda. So we know that f is equals to v upon lambda, which is equals to v is here how much it is given, 24 meter by second, into this is here 2 by 10. That means if it is in the fraction, so we will reciprocal it, this will become 10 upon 2 meter. Okay, so this meter will be down, this is 1 by meter, so this meter and meter will get cancelled, 2 1 are 2, 2 1 are 2, 2 2 are 4, this will become 120 per second. So therefore the number of waves produced in 1 second is equals to 120 waves. Okay, so and the second question, what the second question says, that the time in which one wave is produced. So we need to find the time. So time will be considered as t is equals to how much, and we already know the frequency. We know here we have frequency f is equals to 120. So we know here again we have to know the relation between time and the frequency. So time is equals to 1 by frequency, so t is equals to 1 by f, and this is equals to 1 upon 120. So 120 will divide 1, 0 0.0, this will not go, again 0 0, so then it will go 8 times 8 12 are 96, 0 4 0, then we can add 1 0, 3 times 36, 0, then 4 0, again it's coming 3 times 36, 0. Okay, it will keep on this 400, so we can leave up to here, this will be here 0.00833, so which can be written in the order of magnitude form. It will be 8, then we'll see the decimal 1 2 3, so here 3 into will make the power of 10, so if you are sitting right hand side, so this will be -3, this is a time second. Okay, therefore we can write here the time in which one wave is produced is equals to 8.3 into 10 to the power minus 3 second. All right, so we'll move on to question number 2. And the question number 2 is, calculate the minimum distance in which the air required between the in the air required between the sound of source of sound and the obstacle to hear an echo. Take the speed of the sound. Speed of the sound is given here. Okay, so speed of the sound is given here, and what is given? Okay, so we know in the air velocity of the sound, that means minimum time required to hear an echo is 0.1 second. Okay, if the source is here, also we'll say hello, the source. So the source, okay, and produces the sound, and this is the reflecting surface. This is your obstacle. So it will say hello, and it will travel d distance, and it will return back d distance only. And the time taken here, minimum time is here 0.1, and the velocity of the sound in air is given how much? 350 meter per second. So we'll write here whatever is given. So velocity of the sound in air is given 350 meter per second, and we know that minimum time will be 0.1 second. Okay, and what is there? So we have to find the distance is equals to how much. For the echo, distance formula will be v is equals to 2d upon t. D will be here, v into t upon this 2 will come down. So right here we know distance is equals to velocity into time upon 2, which will be equals to v is how much here? V is given 350, okay, meter per second, into time is here 0.1 second divided by 2. So this will become how much? 2 1 are 2, 2 1 are 2, 2 7 are 14, 2 5 are 10. So this will become 17.5, and since we are finding distance, this will be meter. So here this unit is meter by second into second. Second will cancel, the unit will be meter. Minimum distance required is equals to 17.5 meter. All right, you can see. Now we move on to third question. What should be the minimum distance between the source and reflector in water so that echo is heard distinctly? Suppose, and the speed of the sound is given in water, in given is here, velocity of the sound in water is here 1400 meter per second. So in water, so if the source, this is your source, say there is a, say, boat is there, okay, and it will create the sound here, and say there is a iceberg, okay, is here. So it will produce the sound, and the sound will travel d distance, and it has to return back also d distance. Minimum time for an echo to be heard distinctly is 0.1 second. So taking this principle, we can write here whatever is given here. What is given here? Velocity of sound in water. It's similar question. Okay, is 1400 meter per second, and time, we know that time required is 0.1 second, and what we have to find? We have to find distance again. How much? We already got the formula, distance is equals to v into t upon 2. This is the formula for echo. Okay, so we write, we know distance is equals to v into t upon 2. this is equals to velocity is a 1400, okay, and time is here 0.1 divided by 2. This will be equals to 1 are 2, 7 are 14, 0, 0. This is a 700 into 1 will be 70.0, which can be written as 70 meter. Therefore, the minimum distance between the source and the reflector in water, the minimum distance required to hear distinct echo in water is equals to 70 meter. All right. So now we move on to question number 4. A man standing 25 meter away from a wall produces a sound and receives the reflected sound. Calculate the time after which he receives the reflected sound if the speed of sound in air is this much. Velocity of the sound in air is given. So again it is 350 meter per second. So if it is given, we write the given value. If it is not given, we can write approximately 340 meter per second. All right. And here it says that a man is standing in front of the wall. We have to calculate how much time is required for the echo. Okay. So here we can write here. Then whatever is given. So first we write down the given. A man is standing 25 meter away. So distance is given 25 meter. And what is given here? Calculate the time after which, okay, reflected sound. So another, the velocity of the sound. So we are doing here A. So velocity of the sound is given. Velocity of the sound in air is given 350 meter per second. So then we write here, we have to find here is time is equals to how much. We know that the formula is here, like velocity of the sound is equals to 2d upon t. Since we have to find the t, this will be 2d upon v. So here we use this formula. So we write, we know t is equals to 2d upon v. Here 2 into distance is how much? 25 meter. Both the units are same. Okay, all right. Then velocity of the sound is at 350. Okay. And now what is there? This is equals to, now we'll cancel first. 5 are 25, 7 are 35, 0. 1 are 5, 1 are 4 are 20. 1 are 2, 7 are 14. So how much we got here? We got 1 upon 7. Now 7 will divide here. 7 will divide 1. 0 point, then it will come 0. 7 1 are 7. 10 minus 7, 3, 0. 7 4 are 28. Sorry, 28. Then this will become 2 0. 7 2 are 14. 6 0. 7 8 are 56. 4 0. It will keep on going. So we can conclude here only. So this is equal to, we can write 0.14. Since this number is greater than 5, we can add 1. 3 second. Time is equal to 0.143 second. Minimum time for an echo is how much? 0.1 second. Okay, so this is more than 0.1 second, so we can say that yes, okay, the man will be able to hear a distinct echo, then right here echo, since the time is 0.143 second, which is greater than the minimum minimum time required for distinct echo. A radar sends a signal to an aeroplane at a distance 300 km away with a speed of 3 into 10 to the power 8 meter per second. After how much time is the signal received back after reflecting from the aeroplane? Okay, so here aeroplane, aeroplane is there. Okay, I'm very good in drawing. Okay, don't laugh at my drawings. Okay, aeroplane. So like paper aeroplane we used to make. Okay, it's same like that aeroplane. Wow, it's a beautiful aeroplane. You can see here. Okay, it's going, and there is a building. Radar is sent from the building, big building. You can see that near the airports, right? What is it? Okay, so big buildings here. Okay, from here the radar. Okay, from the like mic structure, the radar is sent from here. The sound is signal is sent from the radar. Okay, the signal is sent, and this is how much, what is the distance between the airplane and this building is 300 kilometer. It is given in kilometer, remember that. Okay, here distance is given 300 kilometer. So since this is meter per second, so we have to convert in this into meter. So 3000 into 1000 meter is equals to 3 into 10 to the power 1 2 3 4 5 5 meter we can write. And what is given? Speed of the sound, velocity of the sound is given 3 into 10 to the power 8 meter v per second. We have to calculate the time is equals to how much. We know that v is equals to 2d upon t. Okay, every time you do, you write the formula, so you'll be used to with this. So t is equals to 2d upon v. All right, so we know t is equals to 2d upon v. So 2 into distance is here, 3 into 10 to the power 5 meter, and this will be 3 into 10 to the power 8 meter. So here we can have this and this cancel. Okay, and this will be equals to how much? 2 into 10 to the power 5. When it will come up, this will become minus 8. This will be equals to 2 into 10 to the power minus 3. So since time second. Okay, so therefore required time is equals to 2 into 10 to the power minus 3 second. Now we move on to question number 6. A man standing 48 meters away from a wall fires a gun. Calculate the time after which an echo is heard. The speed of the sound is given. So here man, okay, this is a danger man, okay, because he is firing a gun. Bhai of Washipur. Okay, so this fires a gun. What sound will come? No? Okay, and after firing one, the sound will travel here. Okay, echo heard. Okay, wall is there. So great wall again. The Great Wall of China is there, right? There is a Great Wall of China. Near that, a man. That means a bhai. Okay, bhai is there. Bhai is there. He fires a gun. Okay, and it travel this distance. Okay, and it will return back also, right? So but this distance is given. How much is the distance between this? Is 48 meter is the distance. And here velocity of the sound in air is given. Here again 200 and sorry 320 meter per second. What is given? A man is standing this. Here distance is given is 48 meter, and calculate the time after which, and the velocity of the sound in air, it's given 320 meter per second, and we have to calculate time again, how much is the time required. Then we know the formula again. V is equals to 2d upon t. So this is the simple speed, distance, and time formula. Speed is equals, we know, we have been doing in math, speed is equals to distance upon time. So here speed is written as v, distance is here small d, and time is here small t. This will be 2d upon the v will come down. Okay, this formula we write, we know time is equals to 2d upon v. Okay, so this is equals to 2, distance is how much here, 48 meter, whole divided by 320. Again I'm telling you guys, this, the unit of all the particles should be same. Okay, this is equals to now, so we have to cancel out here. So how will cancel? 2 1 are 2, 2 1 are 2, 2 6 are 12, 2 0 are 0. Okay, 16 will go to 16 1 0 10, 16 1 are 16, 16 3 are 48. Okay, so it's coming here 3 upon 10, which can be written as 0 0.3. We can add 0 second. The time after which an echo, what happened, echo is heard is equals to 0 0.3 seconds also, or 0 0.30 second we can write. Okay, 3 seconds, 0 0.3 also we can write, or we can add 0 also. Both the answer will be correct. Okay, or we can write here, or we can write 0 0.3 second. This is also correct. Understood up to here? So let's move on to next question. Okay, here a ship on the surface of water sends a signal and receives it back from the submarine inside water after 4 seconds. Calculate the distance of the submarine from the ship. Speed of the sound in water is 1450 meter per second. So there is a ship. Okay, this is a ship, Titanic. Right, this Titanic is there. Okay, here is Titanic. This deck is also here. Okay, okay, and this Titanic sent a signal to the submarine here. Understood? Ghazi attack. You have seen the submarine, no? Submarine will be like this. I don't know how it look like. Okay, I'm very good in drawing. Okay, so from here it will send a signal. Okay, so what is the distance we have to find out, where the velocity of the sound in water is given. Earlier it was 1400, now it is 1450 meter per second. It is also different. Okay, so you have to concentrate on the given value. Okay, and time required from here will come back and it will return back. The signal return back, and the time takes is 4 seconds. Okay, so here what is given, time is given 4 seconds, and here velocity of the sound in water is given 1450 meter per second, and we have to calculate distance is equals to how much. Okay, now so directly we can write here formula, or else you write v is equals to 2d upon t. Then we have to find the distance, so distance will be v into t. This will go up, divided by 2 will come. This is equals to distance. We write here, we know these sums are very easy. All right. Okay, anyways, d is equals to v into t upon 2. This equals to, v is how much here, v is here 1450 into t is here 4, divided by time is here 2. So we'll cancel out this. 2 1 are 2, 2 2s are 4. So this will be how much. Okay, 2 0 are 0, 2 5 are 10, again 0, 2 4 are, okay, 2 4 are 8, plus 1 9, 2 1 are 2. Okay, it's fine. This is your meter. So this can be written in kilometer. So to write in kilometer, this has to be divided with 1000. Okay, so 2900 divided by 1000 kilometer, which is equals to how much? 2.9 kilometer. So whenever it is more than 1000, then we can convert into kilometer. If you write the answer up to here also, it's all right. Okay, so therefore the distance between a ship and the submarine is equals to 2.9 kilometer. They are 2.9 kilometer away. 2.9 kilometer away from each other. Okay. Now let's move on to next question. Okay. Here it says that a pendulum has a frequency of 5 vibrations per second. An observer starts the pendulum and fires a gun simultaneously. Again, gun. Right, Bhai, another Bhai of Mumbai. He hears an echo from the cliff after 8 vibrations of the pendulum. If the velocity of sound in air is 340 meter per second, find the distance between the cliff and the observer. Okay, so here is what? The pendulum. So let's make the pendulum first. Not make, draw the pendulum first. The pendulum will look like this. Okay, this pendulum, okay, so when it will oscillate here, it will go here, and oscillate here, it will go here. Okay, so from here it will go here. So when it will go from position A, this is a B and C. From here it will move from B to C, C to A, and again A to B. It will make one oscillation. Okay, here. So this pendulum, in 1 second, this pendulum will vibrate for 5 times. Okay, it is given here. And here is a man. Okay, man. Okay, very, very danger man, because he has a gun. Okay, so it will do dichow again. Okay, and this, the sound will travel like this way, and there is a cliff, big mountain, not mountain, hills, cliff is there. Okay, cliff is there, and this is the man. Man is a source, right? And man. So this is your why. Then it fires a gun, and this distance, it will travel a distance. What is given? 5 vibrations, pendulum. Hmm, okay. So then, so he will set the pendulum, and then he fires a gun. After setting a pendulum, fires a gun. After 8 times, when the pendulum will vibrate for 10 times, to and fro motion, to and fro motion. After 8 to and fro motion, the, like he will hear the echo. Okay, the fire of the gun, that means sound for the second time. Okay, and here velocity of the sound in air is given 340 meter per second. So here we have to calculate the distance between, find the distance between the cliff and the observer. So if the question is clear, here whatever is given, first we'll write down that first. Here vibrations. Okay, here what is given? Okay, 5 vibrations is equals to how much? 1 second. So therefore 8 vibrations is equals to 1 into 8 divided by 5 second. So therefore t, time, is equals to 8 upon 5 second. Okay, is equals to 8 upon 5 second. Time is equals to 8 upon 5 seconds. And what is given here? Velocity of the sound in air. This is also air. Is given 340 meter per second. Approximately 340 meter per second. And we have to calculate the distance is equals to how much? We already know that distance is equals to how much? V into T upon 2. So we write here, we know this sum is quite interesting, right? Okay, D is equals to V into T upon 2. This is equals to V is how much? V is how much? V is how much? 340. And T is how much is given? T is given 8 upon 5. And we have upon 2 also. Right. So we'll cancel here. 5 will cancel. 5 1 are 5. 5 6 are 30. 40. 5 8 are 40. Okay. 35 8 are 40. 2 1 are 2. 2 3 are 6. 2 4 are 8. Okay. 5 6 are 30. 5 8 are 40. Okay. This must, and this is equals to, here how much we'll get here? This is equals to 8 4 are 32. 8 3 are 24 plus 3 27. This is distance, so it will be meter. See here also velocity is here, meter unit. How we'll get? Meter per second is second into time is here second. This second will cancel, so meter will left here. Therefore the distance between the cliff and the observer is equals to 272 meter. All right, we'll do this much for today, or else the video will be too long and you'll find boring to see the videos, okay, and see the sums also. And remaining sums we'll do in the next class or in the next session. And also we'll try to solve few questions which are there in the ICSE examinations. Then till then, take care. Bye bye.